First we are going to review some of the topics you have learned as fluid dynamics. The main object or main item for the naval architecture is buoyancy. If you remember, any object has a mass, and by force applied by the gravity, so the mass will give us a force which is weight. By Archimedes' rule, any object is on the water, we have an upward force to the object, which we call it buoyancy. If the object want to be float, buoyancy must be equal to weight. Otherwise, if weight is higher than buoyancy, what will happen? The object will be sink. So we don't want it. We want all the time our vessel to be float. So all the time buoyancy should be equal to weight. If we assume this one as a marine vessel, and the vessel is floated on the water, total weight of the vessel which is, we call it displacement, should be equal to total buoyancy, which is the force applied by the water to the vessel. Just remember, all the time in naval arc, in place of weight, actually we are going to use mass, but we name it weight because in all of our equation, no matter whatever our equation is, we have gravity in one side and gravity in other side, and we can ignore the gravities. So all the time in the naval arc and ship stability, while we're talking about the weight, actually we are going to calculate mass of the object. Total displacement of a vessel, which is weight or mass of the vessel, we are showing that one by a delta, which is beginning of the displacement, and the volume of the vessel, the underwater volume, which is too important for us. This area, we are going to use a lot of so many times this volume. We show that volume by the reverse of the delta. So I'm reviewing that one. Delta is displacement, and that's V is volume of displacement. Okay, why this volume of displacement is important for us? That again